Good day, everyone. Today we'll be talking about the Boyle's Law. What is the Boyle's Law? The Boyle's Law is the law discovered by Robert Boyle in 1662. Robert Boyle is an English physicist and chemist who was born in January 25, 1627. Robert Boyle was the first chemist and physicist to determine that for a fixed amount of gas at a constant temperature, volume is inversely proportional to pressure. Mathematically, using calculus, it means that when volume is or when temperature is held constant, volume is always inversely proportional with pressure. Mathematically, to represent this, pressure is always, or when pressure increases, volume tends to decrease. As there is a decrease in pressure, volume tends to increase. This leads us to the general equation wherein P1 V1 is equal to our P2 V2, where our pressure, or P, is standing for the pressure of the gas and V standing for the volume of the gas. In this type of equation, we divide the two different pressures and volume as our pressure initial, volume initial, and P2 V2, which are our final volume and pressure. So, to apply, or to basically apply the Boyle's Law, we use this picture. In this picture, we are provided with the following. So, we are provided with a container of a particular amount of gas, and we are given at the same time the pressure reading. If you notice, as there is an increase in volume, or the amount of the liquid inside the container, volume tends to decrease. On the other side of the picture, as there is a decrease in the amount of volume of gas, pressure tends to increase here. Why is that so? Because as there is a decrease in the amount of volume, the molecules will become closer to one another, and when there is a limited space for the movement or the motion of molecules, collision will be increasing. So as there is greater collision, force will also increase, thus pressure increases at the same time. So to mathematically apply the Boyle's Law in different sample problems, we have to remember that pressure is always inversely proportional to volume. So again, as there is an increase in pressure, volume decreases. When there is a decrease in pressure, volume tends to increase. Let's try to determine if this type of concept out of the Boyle's Law will be applicable to the sample problem provided. So in this sample problem, a sample of gas occupies a volume of 10 liters at a pressure of 2.0 atm. What would be the pressure of the gas if it is allowed to expand in a 50-liter container at the same temperature? We have to remember that in Boyle's Law problems, temperature is always held constant. So in this problem, we will be applying the three-step procedure in solving for a problem. The first step is to identify the given quantities in the problem. We have 10 liters, we have 2 atm, and we have 50 liters. Again, we have 10 liters, 2 atm, and 50 liters. For us to determine what is unknown in the problem, we have to first identify what quantities are provided in the sample problem. So we have 10 liter, which is the pressure or the volume before changes were done. So this is our V1. We have 2 atm, which refers to the pressure before changes are being done. So we have 2 atm as our initial pressure. And we have 50 liters, which refers to the volume after there was a change. So this refers to our volume 2. So basically, after determining the unknown quantities or the given quantities in the problem, we conclude that P2 becomes our unknown variable or quantity in this problem. So to solve for P2, the following steps are being applied. So we have for the case of solution. So for our solution, we start with the given equation. We have P1 once again, V1 is equal to P2 V2. So since we are looking for P2, all we have to do is to derive the formula of P2 using formula derivation. To derive for the formula for P2, all we have to do is to derive both sides with P2. Since P2 is present in the numerator and at the same time present in the denominator, we cancel them both. Ay, sila.